So today we'll see the new chapter in 10th class of CBSE, that is mensuration, which is very important chapter for SA2. Now mensuration, as we know that in mensuration we deal with the volume, total surface area of 3D figures. Initially, like when you studied mensuration in 6th, 7th or 8th class, you have studied about the 2D figures and you have studied about the area and the perimeter of the 2D figures. Now in this class we will study about the volume, total surface area, curved surface area of 3D figures. 3D figures like cuboid, cube, cylinder, cone, sphere, hemisphere. So we'll see the volume, total surface area and curved surface area of all these 3D figures. We start with the cuboid. So cuboid, as we know, is a 3D figure, and shape of cuboid is, if you see, it's like a box you have, like any geometry box you have, or any box that you use for keeping your pen, pencils. So its shape is like that only. So that figure is known as the cuboid. So that figure is known as a cuboid. The main thing in the cuboid is that the length, breadth and height of the cuboid are all different. That is, length is not equal to breadth and breadth is not equal to height. If sometimes two things can be same, but third thing then can be different. Then only we can say that it is a cuboid. Like if we are saying that length is equal to breadth, then definitely that will not be equal to height, because if all three are equal, that is length, breadth and height, then that figure is known as a cube, not cuboid. So cuboid, generally, if we consider uh, length this length as the L or length of the cuboid, we consider this part as the breadth of the cuboid, and we consider this as the height of the cuboid. So this length, breadth and height of the cuboid should be different. So then only this figure is known as a cuboid. Else if length, breadth and height are same, then it is known as a cube. So now we'll see how to find out the total surface area of the cuboid. Total surface area. So if you see the total surface area of the cuboid is, if you know that cuboid has 6 faces. So as the cuboid has 6 faces, so each face has some surface area. Like this is the front face. Surface area of this face is length into breadth. If you consider only this face, so we know that this front face is a 2D figure, and we know that how to find out the area of the 2D figure. Like if you take a rectangle, so it is a 2D figure, and how to find out the area of a rectangle is, what we will do is we will multiply the length and breadth of the rectangles, that is length into breadth, then we'll get the area of the rectangle. So in this way, as this is the front face which has dimensions length and breadth L and B, so surface area of this face is length into breadth. In the same way as that of front face, there is a back face also which having the same surface area, because dimensions of that face is also same. So surface area of the back face is also length into breadth. Now in the same way, there are 4 more faces, top and bottom. These two are the faces which have the same dimension, and there is 2 side faces, that this face and opposite to this face there is also one other face which has the same dimension as that of, so opposite faces of the cuboid have the same, always have the same dimensions. So as they have the same dimensions, the surface area of the opposite faces is also same. So first we'll see the surface area of this top face, and accordingly we'll see the surface area of the bottom face. So if you know see that the surface dimensions of the top face are length and height, L and height. These are the dimensions of the top face, because this is our length and this is the height. So these are the dimensions. So accordingly, the surface area of this top face is length into height, and accordingly the surface area of the bottom face is also length into height, because the bottom face also has the same dimension. Now there are two side faces which if you see as the dimensions breadth, that is b into h. So as these two side faces has dimension b into h, so surface area of these two faces are b into h plus b into h, because both the side faces have the same dimensions, so their surface area is also same. So from this we can easily write down that twice of LB plus BH plus LH. This is the total surface area of the cuboid. So accordingly, whenever we need to find out the total surface area of the cuboid, we use this formula for finding out the total surface area, that is twice of, in bracket, length into breadth plus breadth into height plus length into height. So from this we'll get the total surface area of the cuboid. Now we will see the lateral surface area, or we can also call it as area of four walls. Four walls means, like if you consider this cuboid is look like a room which is having the six faces. So in the room also, if you see, there are four walls and there is a ceiling and there is a floor. So there are six faces in a room. So accordingly, cuboid also has the six faces. So it means room is just a cuboid. So as room is just a cuboid, so whenever we need to find out the area of the four walls, that is, we need to find out the area of this front face and back face and area of the two side faces, because we need not have to find out the area of the top floor and the bottom floor, because these two are not in the considered as the walls, so we cannot find out the area of the four walls considering these two surfaces. So apart from these two surfaces, there are four surfaces. So we need to find out the area of these four surfaces. So accordingly, we will get the area of the four walls. So if you see the area of the four walls, that is area of the front face and the area of the back face and plus the area of these two side faces. So their area will be length into breadth plus length into breadth plus now area of the side faces. So area of the side faces will be, as you know, see the dimension of the side faces will be breadth into height. Side faces will be breadth into height. So accordingly, dimensions of the side faces are breadth into height. So the area of these faces are breadth into height plus breadth into height. So these are the area of the four walls of the room or four walls of the cuboid. So if we simplify it, what we'll get is twice 2 will be common, because there are these are the opposite faces. So area of the opposite faces are same. So that's why there are length into breadth and length into breadth two times. In the same way, breadth into height and breadth into height is also two times. So that's why we have taken 2 as a common, and in all these things breadth is common, so we'll take b outside the bracket and the remaining part will be in bracket, that is length plus height. So in this way we can find out the area of the four walls, and by using this formula we can easily find out the area of the surface area of the four walls, or we can also say it as a lateral surface area. So area of four walls is also known as the lateral surface area. Now we'll see how to find out the volume of cuboid. So for finding out the volume of cuboid, we use the formula, that is length into breadth into height. It means we multiply the dimensions of cuboid, that is length, breadth and height. So we'll get the volume of the cuboid. And most important thing in this is also is to find out the diagonal of cuboid or diagonal of room. So how to find out the diagonal of room is, whenever we need to find out diagonal of room, it means we need to find out the diagonal which is starting from this end to diagonal which is ending at this point. So if we join this, we will get the diagonal of the room. And how to find out diagonal of a room is, there is a formula for finding out a diagonal of a room, that is under root of L square plus B square plus H square. So if we take the under root of L square, B square and S square and add all these dimensions, then accordingly we will get the diagonal of a cuboid. So in this way we can easily find out the diagonal of the cuboid, or sometimes the question is asked that we need to find out the longest diagonal or longest pole in the room. So accordingly it means we need to find out the diagonal of the room or diagonal of the cuboid. One thing always keep in mind it is that as I have written here, length is equal to breadth is not equal to height. It doesn't mean that it always be the same. It's always be the same. So there are cases in which you will get length not equal to breadth not equal to height. Then also it is cuboid. In some cases you will get length is not equal to breadth but equal to height. Then also it is cuboid. And in some cases you will get length is equal to height and not equal to breadth. Then also it is cuboid. So cuboid means at least one of the dimensions should be different. So if that will be the case, then that figure is considered to be as the cuboid. And these are the formulas which is very important for finding out the things related to cuboid, that is total surface area of four walls or lateral surface area, volume of the cuboid and diagonal of the cuboid. Now we move on to the next 3D figure, that is cube. So as you know, cube is again the red cuboid which is having length equal to breadth equal to height. So it means all three dimensions of the, if all three dimensions of the cuboid are equal, then that cuboid is known as the cube. Like you have seen the dice sometimes. So dice is actually the cube because it is having the length equal to breadth equal to height. So if in any cuboid length equal to breadth equal to height, then that cuboid is always known as the cube. Now in the same way as we have seen the surface area and volume of the cuboid, we will see the surface area and volume of the cube. Now first thing we will see is total surface area of cube. So total surface area of cube, as we know that length, breadth and height are equal, so we'll consider them as length equal to breadth equal to height as A, or side of the cuboid. So A is the side of the cuboid, and as we know that the surface area of the cuboid is twice of L into B plus B into H plus length into H. So this is the total surface area of the cuboid, and as we know that length, breadth and height are equal in cube, and we have taken it as A, so it means it will become twice of A square plus A square plus A square bracket closed. So it will become 2 into 3A square. So it will give us the total surface area, that is 6 into A square. So this is the total surface area of the cube. In this way we can easily find out the lateral surface area of the cube, or area of the four walls. So as we have seen that the lateral surface area of the cuboid is, we have seen that twice B into L plus H, and length, breadth and height are equal, so it will become 2A into A plus A, that is again 2A. So it will give us 4A square. So this is the lateral surface area or area of the four walls of a cube. Now we move on to the volume of cube. So volume of cube, as we know that the volume of cuboid is length into breadth into height, and all three are equal in cube, so it will become A into A into A, that is A cube. So this will be the volume of the cube. And now the last part, that is diagonal of cube. So as we have seen that diagonal in the cuboid was L square plus under root L square plus B square plus H square. And if we keep A instead of L, B and H, because all three are equal, so it will become A square plus A square plus A square. So that will be equal to under root 3A square, or A root 3. So in this way we can find out the diagonal of a cube. So if you remember that all the total surface area, lateral surface area, volume and diagonal of a cuboid, we can easily find out all this thing for the cube also. So now we move on to the next 3D figure, that is right circular cylinder. Right circular cylinder. Most like common thing we have already seen in this right circular cylinder. We day to life we generally see this kind of 3D figure. Like if you take the pencil which is not sharpened, so that figure is also like a right circular cylinder, because its shape is like a cylinder, that is curved part is there, and it's in the whole body, that curved part is there, and its top and bottom part is actually the flat circular surface. So this kind of figure or is always known as the right circular cylinder. Like if you take any pipe or any pole, its vertical part is always curved, means this part is always curved part. So this part is always curved part, and its top and bottom part is the flat circular part. Flat circular part. So this kind of figure is always known as the right circular cylinder. We have seen many kind examples of right circular cylinder. Like as I give you one example of a pencil which is not sharpened, or pole, or you can take it as a you can also take it as a like baseball stick kind of shape figure, baseball stick kind of figure, which is actually having a circular part on all its body, and its top and bottom part is almost like a flat surface. So this kind of figure is also known as the right circular cylinder. Like pen also you can take, in which there is a curved part in its whole body, and its top and bottom part are flat circular surface. So these all these kind of figure are known as the right circular cylinder. Now we'll see how to find out the curved surface area, total surface area, and volume of the right circular cylinder. So first we see the curved surface area. So curved surface area of cylinder. See, in the cylinder, as we see that the bottom and the top part are the flat circular surface, and there is a curved part in all its vertical surface. So this part is this top and bottom part is a circle. So definitely it is having some radius. So let's take this radius as r, and let's take this height of the cylinder as h. So this is the height of the cylinder, or you can say the length of the cylinder. So to find out the curved surface area, we see that whenever we need to find out the we can say the circumference or the perimeter of circle, what we'll do is we use the formula that is 2 pi r. So this formula is used for finding out the circumference or the perimeter of the circle. So as you can see that cylinder is actually divided into infinite number of circles. So like if you divide this cylinder into circles, you can get infinite number of circles, and each circle is having the same radius, and therefore each circle is having the same radius. So circumference or perimeter of these circles are same, which is equal to 2 pi r. And as these circles are extended up to the height h, that is the height of the cylinder, so that's why we multiply it by h, because we have to add 2 pi r to h times, because the height of the cylinder is h. So if we add 2 pi r to h times, or we multiply 2 pi r with h, what we'll get? We'll get the curved surface area of the right circular cylinder, that is 2 pi r into h. So in this way we can find out the curved surface area of right circular cylinder. So now we'll find out the total surface area of the right circular cylinder. So now total surface area includes two more parts, that is area of the circle that is at the top of the cylinder, and area of the circle which is at the bottom of the cylinder, because we have not considered that area in the curved surface area, because that was actually not the curved part, that was the top and bottom are the flat surfaces, so we will not consider them in the curved surface area. So but that part will be considered in the total surface area. So total surface area includes the curved surface area, that is 2 pi r into h, plus area of the top and the bottom of the cylinder, that is pi r square plus pi r square, that is 2 pi r square. As the top and bottom part are the flat circular surface, so their area will be pi r square of each surface, and as there are two surfaces, so their area will be 2 pi r square. So this will give us the total surface area of the right circular cylinder. And now we'll see the volume of cylinder. So volume of cylinder, how to find out the volume of cylinder is, for finding out the volume of cylinder, we use the formula that is pi r square into h. As we see the volume of the cylinder, that if you see in the cylinder that there are infinite number of circles, and each circle having the area that is pi r square. And if we add pi r square up to h times, because the height of the cylinder is h, so it will get the volume of the cylinder, that is pi r square into h. Why this will get the volume? Because if you consider this top circle, the area of this top circle will be pi r square, and which includes this whole part. So for finding out the volume, we actually have to add this whole part of each circle. So if we add this whole part of each circle up to h times, we'll get pi r square into h, or we'll get the volume of the cylinder. Volume of the cylinder means capacity of this cylinder. So this will give us the volume of the cylinder. So we use this formula for finding out the volume of cylinder, and in this way we can easily find out the curved surface area, total surface area, and volume of the cylinder. And now we move on to the next 3D figure, that is right circular cone. So right circular cone, like cone we have already seen in our day-to-day life, like whenever we take the cone ice cream, its shape is actually like that of a cone. So that's actually the prime example of cone which we see in the day-to-day life. Or sometimes you have seen the happy birthday cap, so it is also in the shape of the cone. Shape of the cone means that its one part is actually the pointed part, and the other part is having the flat circular surface. So this is actually the shape of the cone, which is actually we actually see in the form of ice cream, in the form of happy birthday cap. So this and sometimes in the like top of the circus also we see the tent, which is actually in the form of cone, which is having the flat circular surface on one part, and the cone and the one other part is having the vertex, or other part is having the actually the pointed part. So we consider that's the type of figure as the cone. And as you see that it's one part is the circular part, so that part is all definitely having the radius. So we'll take this radius as r, and we'll take this height of the cone as h. And apart from this r and h, this will take this height as h. And apart from this r and h, the cone is also having this lateral height, and this lateral height, or you can say the curved height, and this curved height will take it as L. So whenever we need to find out the value of L, when the h and r are given, so if you see, this is actually forming the right angled triangle. If you see this this h, r and L combinedly is forming the right angled triangle. So whenever we need to find out the value of h, we use the Pythagoras theorem, that is L square is equal to h square plus r square, and we'll get the value of L is equal to under root of h square plus r square. So in this way we generally find out the value of L in case of right circular cylinder. Now for finding out the curved surface area in case of the right circular cylinder, we generally use this formula, that is pi r L, which is actually having this L as the lateral height, or and this r as the radius of the circular part, which is having at the bottom of the right circular cone. So this is actually the curved surface area of the cone. In this same way, like as we seen in the cylinder, that in the curved surface area does not include the circular part, which is at the bottom and top of the cylinder. In the same way, for the cone also, we does not include the circular part, which is at the bottom or top of the cone. So but in the total surface area, we definitely include that. So it will become pi r L plus area of the circular part, that is pi r square. So this will give us the total surface area of the cone, and accordingly from this also we can find out the volume of the right circular cone, and that is actually considered as the 1 by 3 pi r square h, that is 1/3 of the volume of the right circular cylinder. So these are the basic formulas which we generally use in finding out the curved surface area, total surface area, and volume of these 3D figures which I studied, that is cuboid, cube, cylinder, and cone.